Hello, chemistry students. Here we are in Unit 2 still. We're now on Lesson 2, which is classification of matter. There's two different videos for this one. One, which we're going to do here, qualitative versus quantitative, and physical versus chemical. And then the next one is actually the classification of matter video. So let's get started. So the objective here is to be able to distinguish between a qualitative and a quantitative observation and to make conclusions about chemical properties and physical properties as they pertain to water. We're going to have a lab that goes along with the physical and chemical properties of water. We're going to talk about some different qualitative and quantitative observations that are going to show up in the water lab, and then we're going to hopefully be able to relate this to chemical properties of water and their uses in the natural world. The next actual lesson is all about the chemical and physical properties of water. So let's start with qualitative versus quantitative. So here I have these apples and a little yardsticks ruler on the right hand side. So how would you describe those apples? You might say the apple is red. You might say the apple was sweet if you tasted it. You might say the apple was approximately 6 centimeters tall. I guess that's about right, using this number right here, about that. You could probably say there's 2.5 apples. Or you could say that they maybe had a stem. One stem had a leaf. Make a comment about how the one is cut in half and you can see seeds, but there's a whole different ways you can describe these apples. These descriptions will be classified as either qualitative or quantitative. To do that, we're going to look at the root word of qualitative and quantitative. As far as qualitative, would be quality. When we're talking about quality, we've talked about some sensations that don't have to do anything with counting. And the root word for quantitative is quantity, and that's where we are going to start talking about words that have something to do with numbers. So if I classify these words as quantitative and qualitative, I might first say that the red was a qualitative observation. The sweet was a qualitative observation. Maybe the 2.5 apples was quantitative, and 6 centimeters tall was quantitative. Can you tell with the patterns what qualitative and quantitative mean? So we're looking at qualitative property where we can look at the shape, maybe the color, maybe the smell, maybe the text, maybe a lot of sensual components, things you feel with your hands, touch, smell, see, taste. Those are all things that you might be able to identify via qualitative properties. A qualitative property is one that uses your senses. So you're looking at, again, touch, taste, sight, hearing, smell. Okay? You can use your senses to describe the type of matter. Whereas a quantitative property would be using numbers. How many, how long, how much does it weigh? Numbers. So for instance, mass is an example of a quantitative measurement. So is volume. So it would be weight. Weight is different than mass because of, go back to physics. Might talk about length or the amount, how many are there? So there's a lot of different ways you can attach numbers to your observation. So let's look at this graph. Did it rain more in DC or in Denver? Now looking at the legend here, here's where DC is, over here in this green, and Denver's out here in this yellow, so which one does it rain more? Well, obviously it rains more in DC because DC with the green and the blues are on the higher end of that scale. So it rains more in DC than it does in Denver. Now, is there any numbers associated with that? No. We're just looking at average monthly precipitation and giving them some generic highs and lows. But if we look at the same graph and we say, how much more did it rain in DC? Well, now we're looking at a quantitative measurement. You can kind of see, and I guess I have to guess here, that the DC is looks like in the middle of a light blue, which looks like it's 1,000. And the Denver, I can't tell whether it's on the dark yellow or the light yellow. I'm going to go with the dark yellow. I don't know. That's how I feel. So if I do this, then I find out that it rains 750 millimeters more in DC than in Denver. So yes, this was 1,000. This was the light blue, and this was the darker color. That was the 250. 1,000 minus 250. It rained 750 millimeters more in Denver, in DC than in Denver. So which one is qualitative? Well, qualitative would be the one where it says it just gets measured more. There's no numbers associated with it. It rains more in DC than in Denver. But the fact that it rained 750 millimeters more in DC than Denver, that would be quantitative. Again, looking at numbers. Need more practice? Let's check this one out. So where did it rain more, Dallas or Seattle? Looks to me like it's Seattle. Yep, it rained more in Seattle than Dallas. Got the dark blues up there, and Dallas looks like it's in the yellow range. And if I do the same thing, try to do the math here, this should be interesting. We're going to say maybe Seattle is in we'll give it, I'm going to go with this dark purple with the 2,000. And looks like this is in the lighter green. That's at 750. So 2,000 minus 750, let's see if that's what they get. Nope, they said that this is on purple. This is on purple. 2,500 minus 750 would give you the 1,750 millimeters more in Seattle than in Dallas. Qualitative versus quantitative. It rained 1,750 more millimeters in Seattle than Dallas. That would be a quantitative measurement. It rained just more in DC than Denver. That would be qualitative. It has nothing to do with the actual slide we just saw. Okay. So in summary, description can be classified as either numerical, measurable, or identified through the census. Descriptions that are numerical are classified as quantitative. And the observations that go through your senses that are not measured and are not represented by a number, those are qualitative. So qualitative, quantitative is with numbers, qualitative is without, is using the census. Okay, next thing, let's look at chemical versus physical properties and chemical versus physical changes. Now, this is something you should have done in middle school. I say that a lot in this class. Should have said in middle school, and this is why I say that is in the past when I've done this chemistry, earth, space, science, I sometimes will give a diagnostic at the beginning to see what is covered. And in order to write that diagnostic, one of my former colleagues and I reached out to Sykesville Middle School and says, give us your final exam for physical science, which was 6th grade. And they said they covered physical and chemical properties and physical and chemical changes. This should be a bit of a review. So let's talk about properties. So a chemical property is one where you see a change in the composition of the chemical formula that's occurring. So for instance, iron, Fe on the periodic table, becoming rust. Rust is either iron oxide, Fe2O3 or FeO, depending on the temperature that it happens, but it's going to have something that has oxygen. The chemical formula has changed. It's gone from iron, a single element from the periodic table, to iron oxide, something that's iron combined with oxygen. The chemical formula has changed. That would be a chemical property. Can it rust? That's a chemical property. Rustability, is that a chemical property? So the ability to rust is a chemical property. Another chemical property might be whether or not something is able to react with oxygen to form carbon dioxide and water. That means, is it combustible? Well, methane, if you were to take methane and react it with oxygen, it would make carbon dioxide, water, and it would make some heat. So it's in the natural gas line, one of the two element components that are in a natural gas that may be coming into your stove at home or your fireplace if you have a gas fireplace. It burns. So the fact that methane, CH4, becomes, CH4 becomes carbon dioxide. See the chemical change. The carbon is paired up with hydrogens, then it's paired up with oxygens. The hydrogens are paired up with the carbons. Here they're paired up with the oxygens. So everything changes, and you have a different chemical formula. Therefore, the ability to combustibility is a chemical property. And there's the same thing. Chemical transformation involves a change in the way atoms and molecules are bonded together. The same thing, the methane reaction with oxygen to give you carbon dioxide and water. Notice that the bonds here between the carbons and the hydrogens broke. The bonds between the oxygen and oxygens broke, and everybody rearranged themselves accordingly to make the new molecule. So we have a change in the chemical composition, chemical formula, therefore we have a chemical property. And those connections are called chemical bonds. Notice that the chemical bonds are different on the left-hand side versus the right-hand side. Now, what's the classic example of something that's not a chemical property? That would be boiling point. Can it boil? At what temperature does it boil? Well, with water in its liquid state is H2O. Water in its steam state is H2O. So it really doesn't matter whether it's in a liquid state or a gaseous state, it's still the same chemical formula. So when something is boiling, it is not undergoing a chemical change, it's undergoing a physical change. If the overall molecule does not change, then, and all the bonds stay the same, then the boiling point is not a chemical property. That would be a physical property. But we can't necessarily see a chemical formula. So how would we see in the lab something underwent a chemical change? Well, the three biggies are light is released, so you'll see some type of energy, or light, it'll get warm, it'll get cold, might shine a little bit, might flicker with light. A precipitate form, that's where two pieces come together, and you get this clouding up of the solutions, forming a solid. Or you might get gas bubbles. That's almost always an indication. Shy of boiling, you have the reaction where two things react and it fizzes. That would be a chemical change. So some examples of chemical properties would be smell, reactivity, flammability. Taste and smell are both chemical senses. The tongue is a central muscle. Contagious taste buds runs through receptors in the cavity and changes them through the olfactory bulb in the brain. So you have both taste and smell are chemical properties. Reactivity, flammability, does it react, does it catch fire? Other chemical changes, we talked about the iron becoming iron oxides. That rusting is a chemical change. In chemistry, materials undergo a chemical change. They're said to be reacting. The iron reacts with oxygen to make the iron oxides. So what we have here is a chemical reaction. If the different chemicals are reacting with one another and making a new product, that's a chemical reaction. If we have a chemical reaction taking place, then we have a chemical change taking place. And during that chemical reaction, new materials are always formed with new bonding patterns. So I can't tell whether something's like physical or chemical change. You're looking purely at, do I have the same material, the same composition afterwards as I did in the beginning? If the chemical makeup of the substance is the same in the beginning and in the end, then I don't have a chemical change, I have a physical change. So boiling water, physical change. In a chemical change, you have a new material being formed. And when that new material is being formed, you're going to get a very different type of substance. And that substance that you might see is going to be a different chemical formula. So for instance, burning wood. If I burn wood, I start off with cellulose, and then in the end I get ash, water vapor, smoke, all of which are indications that a chemical change has taken place. Let's talk about physical properties. Some physical properties. There's a property that can be described using a look or a feel, kind of like going towards those qualitative observations. So, for instance, color is a physical property. If I look at something and say, that's blue, I don't change the makeup of the material, right? Hardness. How hard is it? Well, if I knock on something, I'm not going to change the makeup of the substance, so that's going to be a physical property. How dense it is, we did this with the rocks. Did we change the rocks by finding out the density of the rocks? No, we just got them wet, but we didn't change the chemical makeup. Texture, what do they feel like? Feeling something and say, is it rough? Well, in determining whether it's rough, I don't think we actually have changing in the chemical formula. And of course, the phase is a solid, liquid, or gas. So, physical properties. If you're changing conditions but does not change the substance, you've got a physical property. For example, if I take water and freeze it, it's still water. So that's not, the freezing is not a chemical property, it's a physical property. For physical changes, the physical appearance may change, however, it's not going to change the composition of the matter. Some other examples: size, mass, volume, length. Those are all physical changes. I might be able to change the length. I might be able to change the width. I might be able to change the makeup. Okay. Sorry. The shape. Is it in a round? Is it in a circle? Is it in a square? Is it rough? I can change it. I can take a piece of wood and I can sand it. It's still going to be wood. It's just going to be smoother. Or I can change the state. Obviously, freezing or melting and all that. I can change it from one phase to another. And again, reinforcing the whole melting and freezing being physical changes. The only difference between water molecules are how they're oriented relative to one another. They're still water, H2O. So you can see how they're organized, less organized, and all over the place. And that's the end of our slideshow on part 1 of lesson 2, revolving around quantitative versus qualitative, and then physical versus chemical. I will see you on the next one. Toodles.